Hello everyone.
So this is a demonstration of how to create algorithmic questions in D2L, which some of us will have to do in September. So here's a quick lesson in doing that. So the first thing you need to do is go to your whitespace. We're going to then choose assessments. I'm going to make a quiz. I'll make a new quiz. Give it a name. Time value, money. I'm going to either save and add questions, or I can just create new. So create new question, arithmetic. So when you choose arithmetic, you basically are choosing to make a formula question or an algorithmic question. So click on that. I'm going to start with a very easy one. So ordinary simple annuity, for example. Points are here, difficulty, you can list it, and I'm going to make a question. So I start with what is the maturity value of dollars. So I want this to change. To make this change, you need a variable that will change every time the question is asked. So we put a squiggly bracket. All right, a squiggly bracket makes it a variable. I will call it P for payment and close the squiggly bracket. So what is the maturity value of P dollars at the end of every month for squiggly bracket, because I want this to change as well, Y squiggly bracket, Y, and I'm going to, in this question, I'm going to use years. Years. If money is worth squiggly bracket, I'm going to put a letter R for the percent for what we call the nominal rate per year, compounded monthly. Okay. That's my question. I have three variables, P, Y, and R, all in squiggly brackets. I scroll down all the way to the bottom and I add the variables. So I have P, the minimum payment. You can choose whatever you want. I will say $20 is the minimum. The maximum in this question, you can change it. You can copy this question and change it if you want different types of questions. So I will say $500. Okay, so 2 decimal places, and the step, what that does, it allows it to change. All right, so I will give it steps of $5.75. I don't know, doesn't matter. The next one is Y for the number of years. So I want a minimum of 1 year and a maximum of 30 years. And again, that's your choice. And I will allow that to change by 0.5 years. Okay, I'm going to add another variable. Scroll down. R is the nominal interest rate. I will make that a 0.5% at the very lowest, and let's say 8% at the very highest. I will make that 3 decimal places, and I will allow that to change 0.75. You can change anything depending on how you want to design your question. Again, at the bottom here, you can expand, you can put hints in if you want, and feedback. So I'm not going to deal with that right now. I'm going to go back up here And I'm going to change first my answer precision because I want to be able to test it. So to test it, I want along the way I'm going to get an answer and I want to be able to check. So I start with my formula. My formula is going to be this. I've written it out. The future value equals PMT times 1 plus I to the power of n minus 1 over I. I know that I in this case is going to be the nominal interest rate divided by 100 and divided by 12 to give me the periodic, which is I. And the n will be the number of years times 12, gives you the number of payments. So then I go back to here and I'm going to build my formula. So you can build it all at once if you're good at this thing, at these things. So you can write it out and type it in, but this gives me a bit of a headache sometimes because if you miss a bracket and whatever, it's just more trouble than it's worth. So I just check it as I build it. R, nominal interest rate, divided by 100, changes it to decimal, and divided by 12 in this case, changes it to the periodic rate per month. Okay, so you can test this. 5.75 divided by 100 divided by 12 is 0.004792. That is correct. So we're good so far. The next thing I need to do is I need to add 1 to it because our formula says 1 plus I. So that's I so far. I'm going to add 1 to it plus 1. Right? I'm going to put that in a big bracket, a regular round bracket, not a squiggly bracket. Okay, that adds 1 to it. Again, you can test it. 4.25% divided by 100 divided by 12 plus 1 is 1.003542. Done. So now I have 1 plus I. So I need to bring it to the power of the number of payments. So hat is the command to bring an exponent into play, a regular bracket, a round bracket, and it's going to be a squiggly bracket, the number of years, that's the variable, times 12, and close the bracket with a round bracket. All right, that brings it to the power of n. Again, if you want to test it, click it, and it's 8% divided by 12. You want to check, it's just 8 divided by 12 divided by 100 divided by 12 plus 1 to the power of, in this case, 23, right? 23 times 12. 6.258207, which is correct. Okay, I have this brought to the power of 12 now, and then I'm going to enclose this in another set of brackets, and I'm going to subtract 1 from it. All right, because that's that 1 there. I'm going to divide everything by I. So when I subtract 1, I'm going to have to put this in a bracket. I'm going to slash divide, and I'm going to put another round bracket, and I have to put an R for the nominal rate divided by 100 divided by 12 and close the bracket. Test it. If you get an error, it will show here and it'll tell you have too many brackets or you have some issue. So right now my answer is 72.058. Let's check it with the numbers that we have. 7.25% divided by 12. That's the monthly rate. add 1 to it, the 1 plus I. I'm going to bring it to the power of 5 times 12, 60, right? Subtract 1 from it. And say in that case, divide it by 7.25% divided by 12, close the bracket, equals 72.058078, which is correct. Everything's done correctly so far. Last thing to do is to multiply everything by P, the payments. So again, last step is to multiply by the number of by the payment amount per month. So I'm just going to press a star for multiplication and a squiggly bracket, and P, which indicates that it's a variable again, and that's my formula. Test. Let's check it out. 5 divided by 12, oops, 5% divided by 12, store that, plus 1, bring that to the power of 16.5 times 12, subtract 1, and divide it by the nominal interest rate again, the periodic interest rate, and multiply everything by 221.25. And there you got it. And there you have 67,860.37. In this case, the solution is showing 6 decimal places because that's what I required of it. So let's double check this. Second function, py, 12 and 12. 16.5 times 12 is 198 payments at 5%. No present value. 221.25 is the end of the month payments, and we see that that is 67860.37, which is correct. Okay. So then, once we have that, I know that this is working. All right. I'm going to change my answer back to 2 because I want my answer in dollars and cents. If you want, you can give a precise answer, right? You can give it 1 cent off or whatever, up to you. You can change that to whatever you want, plus or minus 0.01, okay? Or you can keep it like it is. And that's the way we make a algorithmic question. Right? If you want to, you should save it and preview it. Okay? Preview. This is the way it looks like. What is the maturity value of 186.75 at the end of every month for 22.5 years if money is worth 1.250% per year compounded monthly? So let's try it. $22.5 times 12, 270 payments, 1.250%. Nominal, 186.75. Negative is your payment. And I'll compute the future 58,192.64, right? 65. So you put that in, 58,192.65. And at the bottom it tells you the answer as well. Okay, so that's the way it looks like. And you can actually specify how to enter the questions to make it simpler. Do not use commas, don't use a $sign, and so on. Okay, save. And we're done. Hope that helps.